Hi, so in this chapter, we're going to discuss descriptive statistics and essentially what we do with all the information. So in the previous chapter, we talked about just sampling and frequency tables, how to organize, but now what do we do after we organize, right? So descriptive statistics is going to show you how we describe the data and then be able to draw a little bit of conclusions with our data. So let's go ahead and start. So the first thing we want to discuss is stem and leaf graphs, line graphs, and bar graphs. So stem and leaf plots are a different way to represent the data that is similar to a histogram. Except each data value must be broken up in two components, a leaf and a stem. The stem consists of all the digits except for the rightmost one, and the leaf consists of the rightmost digit. So for example, if we had the number 173 as our data point, then 17 would be the stem, and the most right digit, which is the ones place, the 3, would be the leaf. So for Susan Dean's spring calculus class, scores for the first exam were as follows, smallest to largest. So here are the exams for the scores for the exam. The stem and leaf plot shows most scores fell in the 60s, 70s, 80s, and 90s. 8 out of the 31 scores, or approximately 26%, were in the 90s or 100s, a fairly high number of A's. So if we want to go ahead and look at this graph here, essentially the scores for each test are in here, where the 30s, right, students who scored in the 30s, notice the 3 is the stem and the ones place is the leaf. So these are all going to be everything except the rightmost digit. And because we're dealing with scores, these would be the ones place for the scores. So I'll put ones place. And then these would be the tens and then hundreds place, right? Because some students got a perfect score. So therefore, this student here would have been 33. And so we can see in the stem 6 that there are a lot more leaves in the stem 6 than there are in the 3, 4, 5s, right? And then it looks like 90s too. So here is the stem 9 and the leaf is 0. That means that's a 90. A stem 9 with a leaf 2 is 92. And so we could see that these were most frequent scores. So you don't always have to do a frequency table. We can tell that the most frequent scores from a stem and leaf plot. It's just one way to organize data. A frequency polygon is a line graph, and essentially it's a line graph with closed ends. Because we're calling it a polygon, it is a line graph because polygons are lines, right? Like squares, triangles, octagons. But they're enclosed, right? And so line polygons are exactly line graphs, a frequency polygon are just polygons and their edges are lines, but we have to close them at the end. So we're going to do something a little special at the ends of our line graph. So let's go ahead and take a look at an example. So here we have the previous example on the cost of textbooks, where we have the intervals and the midpoints, and here are the frequencies. So all we're going to do is use the midpoints to graph the frequencies and connect each dot with a line. So let's go ahead and do that. So at the midpoint 160, I have a frequency of 4, right? So 160, a frequency of 4. At a midpoint of 200, I have a frequency of 1. And so on. And I'll let you go ahead and do the rest. Okay, so you can see that I have looks like ordered pairs on the first quadrant, right? And so now what we're going to do is connect from left to right, lowest to highest on the cost with lines. So let's go ahead and do that. So I would start at 160 and connect the dot I see at 200. And here from 200 to 240, 240 to 280, 280 to 320, and so on. And so essentially this is the polygon, right? The straight edges. So notice here that this is a line graph, but it's not a polygon because it should be closed, right? Like that. Right, so it looks like it's enclosed, but it's not. It's very open. Like if I had bugs in here, bugs could easily get out and crawl out. What we want is enclose it so bugs don't go in or get out, right? So this is what we do in statistics. How we resolve this is we just go ahead and enclose. So what we do is we draw a line from the very first point to the origin and then do a zigzag towards the x-axis, and same with the right end point. So let's go ahead and do that, and I'll change the color to maybe blue so we know that it's going to be different. And what we essentially do is draw a line and then to the origin about, leave a little bit like a centimeter, zigzag it down, zigzag like that. And so doing it at the end here, draw it down and then zigzag at the end. And so you can see that the reason why we put those zigzags at the end is to tell the reader those are not included points. They are not part of our data set. They're out of the scope, but we need to close it due to the line graph being a frequency polygon. And so we just put those little zigzags to let the reader know that. Okay, and that's really all there is to it with a line graph. You just take the midpoints or just the numbers from the frequency table if you don't have classes, and you just plot the points and then connect them with dots, and then you use the endpoints to do the zigzags. So now let's look at bar graphs. So bar graphs are a little different. It's a display of a rectangular bar for each category, where the length of the bar indicates the frequency. There is a horizontal and vertical axis. We only use the first quadrant, and the horizontal axis are the categories, and the vertical axis are the frequencies. So let's look at an example. So by the end of 2011, Facebook had over 146 million users in the US. The table shows 3 age groups, the number of users in each age group, and the proportion of users in each age group. Construct a bar graph using this data. So all we have to do here is draw the first quadrant, label categories on the x-axis, frequencies on the y-axis, and then just draw rectangles as high as the frequencies. So let's go ahead and do that. Let me go ahead and first draw the first quadrant. And so, and then on the horizontal axis, go ahead and draw the categories. So our categories here are the age groups. So we'll put age groups. So in this case, the ages are being treated as categories and not quantitative data. So we have to be careful here when we draw our tick marks. So here would be 13 to 25. And since we're using these as categorical, using these as categories, we go ahead and make sure the bars do not touch, and we go ahead and put that categories a little farther than we would think from each other. So the next one would probably be in the middle, 26 to 44, and the last one probably way over here, 45 to 64. The next step would be to label your y-axis. And so the y-axis would be the frequency. In our case, we're going to be using the relative frequency in the table with proportions. So we would say, here's the proportion. So we could see that the proportions here are 45%, 36%, and 19%. So whatever I label here on the y-axis here should correspond to these percentages here. Now, how should I do that? How should I write those tick marks? Should I do it every 1%, 1, 2, 3, 4, 5, all the way up to 45%? No, I don't think so. Should I go all the way to 100%? Well, maybe not, because the highest percentage is the age group 13 to 25, which is 45%. So what is a reasonable maximum Y unit that we could put, or percentage? If you saw a 50%, I think that's a great idea. And maybe we can make our tick marks every 10%, right? So here I would put 10%, 20%, 30%, 40%, and 50%. Great. And now we can ready to draw our boxes. So when we draw our boxes, let's go ahead. I'll use a different color. From 13 to 25, we have 45%. So probably here, here, here. So notice that when we draw our rectangle, it is around the category. So the category tick mark is the center of the bar, and we draw the bar at the height of the frequency. Now this may seem so elementary to you, but really statistics is very mathematical, right? And very tedious. And so there is a mathematical method to drawing even a bar graph. So that's why I'm kind of over explaining it. And then we can go ahead and do it for every category after. So let's do 36, which is about here. $45 to $64, which is 19%, which is about here. Great, and then you could shade it in a nice blue color if you wanted. It's really up to you how nice you want to make the graph. And also what I've seen in software for statistics, like statistical software, is that they put the frequency above the bar, like they would put 45% here, 36% here, and 19% here, just to make it look nice. Now, a bar graph, once again, I just want to write some notes. The bar graphs themselves have categories on the x-axis, and also have the bars do not touch. Okay, and then we keep them separate because it's categories. We can't blend them. They don't really blend well. And so, and those are the two things to really remember about the bar graphs.